So as we know in yesterday's class, we discussed characteristics of sound. So three things we discussed totally. The first one is what, everybody? First one is loudness. So loudness is related to what, guys? Anyone? Loudness is related to something. Yes, please.
Intelligible sound.
Loudness is related to what? Amplitude. Yeah, so amplitude. So the amplitude is very small. That is what smaller amplitude. If the amplitude is, that is what based upon the amplitude will decide the loudness. Either it is a soft sound or loud sound. If the amplitude is small, the small amplitude, we say it is a soft sound or loud sound. Everybody, it is the soft sound. If loudness, that is what, if the large amplitude is very, very large, then which we used to call it as what sound? All of you. Loud sound. So this loudness is actually, the loudness is directly proportional to square of amplitude, and this loudness is measured in, how will measure everybody? Loudness is measured in decibels. So that is what dB. So we discussed that how this loudness and what is the factors, how many factors affecting the decibels, and sorry, this loudness, anybody? Factors on which the loudness is depends. If you're not speaking, we'll stop the classes. No. Yeah.
Three factors.
Loudness. The first one is on amplitude. So it will be directly proportional to amplitude or square of amplitude. Second one. What is the second one? Everybody. Depends on distance between the listener. So inversely proportional or directly proportional? Inversely. Inversely on the distance. Distance between what, guys? Distance between
Listener and the
between listener and source. And the third one is, what is the third one?
density of a
Density of
medium.
medium. So density of medium. So because today's class we are going to talk about this only now. So now next we discuss about pitch. So we all knows that pitch is related to, pitch is related to what? All of you. Pitch is related to
Frequency.
frequency. So greater the frequency, higher will be the pitch. Lower the frequency, low pitch. That is what low frequency, low pitch, and high frequency, high pitch. That is what we used to say. Low frequency, low pitch, low pitch sound, and high frequency. High frequency means what? All of you. Yeah. So high frequency
Pitch.
means high pitch. So that is what we discuss. So and then we discuss the main characteristic. What is that, everybody? Which will help us to distinguish.
Quality of
Yes. Quality. That is what is the third one, which we used to call it as a quality, or we can call it as a timber. So this is the one which will help us to distinguish between the sounds of, distinguish between the sounds of, here quality or timber means immediately one point you have to remember, that is what this point, distinguish between the sounds of what, everybody? Same loudness and as well as, yeah, same loudness and as well as pitch. So pitch and frequency is same. Sorry, pitch and loudness is same. But what is not same? Anybody? It is depends upon what? There is a word I told you. Anyone?
waveform.
So different instruments, they have a different waveform. That is what we used to call it as a, yes please, a single frequency. What is to call? A single frequency of a, yes.
Note or
Single frequency of a any kind of a single frequency, what we used to call, everybody, which we used to call it as a, okay. Now Suppose if I take a guitar, you all knows that, okay? So it is used to produce, it is having a say, one string or many strings are there, everybody? Many strings are there. So now the guitar is producing one single frequency or multiple frequencies. Suppose if I plug the wires, it will produce us multiple frequencies or single frequency, everybody. So multiple
frequency.
frequency. Am I right or wrong? So one graph, multiple frequencies it will be producing. So this is what we used to call it as making the multiple frequencies, which is known it as what we used to call all of you.
Note.
Note. Okay. So that is what a musical instrument produces a sound of several frequencies. That is what we should call it as note. So hope you all understand, everybody. So till here we studied that. Then now we are going to study speed of a sound in different medias. So please keep reading. Speed of a sound. Speed of sound in different media. So what is the three well-known medias for us? Anybody? Mediums. So first of all, we have been proved that medium is compulsory for the propagation of sound. Am I right or wrong? Everybody? Is it possible to propagate the sound without medium? Anybody? No. So medium is compulsory for to propagate the sound. So that's what we have been taken. So generally we are having a three mediums. What is the three mediums we have? Everybody? One is solid medium, another one is liquid medium, another one is what? Gas medium. So now, third point in loudness. What is the third point in loudness? Everybody, density of the medium is directly proportional or inversely proportional? Everybody.
Directly proportional.
Directly proportional. So that is what generally we says. So now coming to the solids. So let density of solids is ds, density of liquids is dl, density of gas is dc. So now tell me which is greater. Generally which is greater? Generally, density of solids is greater than density of liquids is greater than density of gases. Is it right or wrong? Everybody.
Yes,
Generally,
sir.
yes, some
Yes, sir.
gases, some liquids are more denser than solids. That is always accepted. But generally, I'm saying. So generally, if density of solids is greater than density of liquids is greater than density of gases, then coming to the speed of sound. Speed of sound is also generally, what is that everybody? Speed of sound in solids is greater than speed of sound in liquids is greater than speed of sound in gases. Higher the density, greater will be the speed. Higher the density, greater will be the, yes, please,
Speed.
speed. So that is what you have to remember. Sir, what is the reason? Anybody knows till now? So of course, even from 8th class, you might be studied solids, sound will travel faster. Sound will travel faster. Anybody? Any reason? Only one reason. What is the basic difference between solids, liquids, and gases? What makes you to define the solids, liquids, and gases? Anybody? I want to answer, please. Everybody, please involve and answer. What makes you? How
Density.
you people defines? Anyone?
The arrangement of particles and the density.
Yes. Arrangement of particles, not density and all. Of course, say for example, I take mercury is denser than iron. Am I right or wrong? Will you all agree with me? So what is the density formula? Density equals to what is the formula? Everybody?
Mass
Density is
by
equals to mass by volume. So if I taken density of mercury is 13.6 gram per cubic centimeter. Density of iron, if have been taken, 7.8 gram per cubic centimeter. So which is greater now? Density liquid is mercury is a liquid.
Mercury.
Yeah. That's what I'm saying you. So generally I'm saying. Are you clear? Yes,
Yes, sir.
Padma, plasma is there, another fifth state is there, but that is all not existed on the earth. Okay? Clear?
Yes, sir.
Yeah. So that is what. So now So generally, which is greater density? Generally, solids having greater like high density than liquids. So what makes this speed of sound is greater in solids? Reason is arrangement of particles. Please note it. So what exactly the reason behind the fastness of sound in solids is the arrangement of particles. So in solids, particles are how, guys? Closely packed or loosely packed?
Closely packed.
Everybody.
Closely
Closely packed. So particles, the distance between the particles is very, very less. So that, please remember, as they are very close to one another, so the energy transfer from one particle to another particle takes less time or more time. One particle to another particle take less time or more time. Energy transfer. Yes, please. More time. Energy transfer will take less time or more time, guys? Less time. Why less time? Because particles are closer. Clear, guys? Yeah. Clear? Please respond. Everyone?
Yes, sir.
So then, here liquids, particles are little far. So imagine like general distance. Okay. So now it will take a little bit more time or not to pass the energy among the particles. Yes or no, guys?
Yes, sir.
Yes. Now, gases more even faster. Like, sorry, more it will take time. Because why? What is the reason? The particles are more far each other. So that is the only reason behind the fastness of the sound. Why the sound will travel faster in solids? The reason is what, guys? Particles are
Closely.
particles are very close to one another. One another. Since solid particles are very close to one another, so energy transfer from one particle takes one particle to another particle will take less time or more time?
This time.
Less time. So that's why the speed of sound is large. In what? Speed of sound is large. In what?
Solids.
In solids. That's what. Any doubt, anybody? Please let me know or else proceed. Make it fast. Agalya late. What is this, Agalya? Make it quick, everyone. Any doubt, guys? All of you understand? Kishore, Gokul.
Yes, sir.
Yeah, make it fast. Pranav, understand, Pranav? Lingesh, modify your name. Tarunya, I think I changed your number.
Sorry, sir. I will change it.
Completed, everybody?
Yes, sir.
So now, if you have been seen your book, so there is a tabular column. You all can notice it. Just a minute, Amma. Am I audible, everybody? Sorry, my principal man called me, that's why. Am I audible now, everyone?
Yes, sir.
Yes.
Okay, so we'll continue. Sorry for that. So that's what. So now let us see that they have given a speed of sound in Amma once again, Amma, sorry. Am I audible, everybody? I'm sorry for that.
Yes, sir.
So now you can see here, this is the things which is given in our textbook. So speed of sound, different media, temperature. So why, anybody can tell me why, what is the reason behind mentioning the temperature here? See, everybody will read the book. Everybody can go through that, but many people will never notice this one. So note it from now, class 9, 10, 11, 12, wherever you goes, any kind of data, always at a given temperature they will give. So what is the reason behind? Anybody can tell? Anyone? Yes, please. So now it is at 25 degrees Celsius. Actually, this tabular column may be designed 10 years before. So by that time, the average room temperature, is 25 degrees Celsius. So what is the reason behind 25 degrees Celsius? So why can't they mention simply the speed of sound in different media? Have you noticed that speed of sound, I said 340 meter per second, but now book, what is that? You can see here in air. What is that? 346 meter per second. But some other books you have noticed that 330 meter per second. So what makes this difference? Anyone? What is the cause behind that? Anybody? Because of density. So we all knows that depends on what? All of you. Densities depends on temperature. Clear, everybody? So if the temperature rises, density decreases. So that's why always whenever any data we are sharing like regarding physical properties, we must talk about the at temperature. Given temperature is always a measure parameter. 10th class also will be having this. That is what. And what is the speed unit, everyone? What is the unit of speed? All of you. Meter per second. So please remember that. Now you all can see exactly I'm mentioning at 0 degrees Celsius. At 0 degrees Celsius, what is the speed of sound? Anybody? At 0 degrees Celsius, what is the speed of sound? Anyone? 330 meter per second in air. At 22 degrees Celsius, what is the speed of sound? Anybody? 344 meter per second. So that is what is the difference. So, but here you see that. So temperature increases, speed should decrease. Am I right? Is this question is coming to your mind or not? Anybody? Yes? Please answer. Yes or no? But you all notice it. Water density, where it is maximum. If you comes to the 0 degrees Celsius, there is a behavior we have studied. It is a boon for aqua, like polar Polar animals. What is that? Behavior of water. Anybody remember? Anomalous behavior of water. Please respond.
Yes, sir.
Yes. So that is what? Very good. Somebody is remembered. Sanjay. Very good, Sanjay. So anomalous behavior of water. So now you tell me, water, only water it is character, no other substances. Remember, generally, temperature increases, density decreases. Temperature decreases, density increases. Water also same, but between 0 to 4 degrees Celsius, it is entirely different. So water is having maximum density at what temperature? Everybody.
4 degrees Celsius.
Yes, maximum density at 4 degrees Celsius. That is what 1 gram per cubic centimeter. So that is the reason the water is the air speed. Same way, understanding? If the temperature is lower, here you see is at a 0 degrees Celsius, the speed of sound in air is 331 meter per second. And if it is 22 degrees room temperature, 344 meter per second. But this tabular column is set by what temperature? Anybody? Set by
25.
what temperature? 25 degrees. Then what is the temperature? What is the speed of sound in air? Check it, everybody.
346.
346 meter per second. Do you all understand, Amma? Please respond, everybody. Yes, please.
Yes, sir.
So that is
Yes,
what.
sir.
So every temperatures also matters, particularly if you come about to the air. Now you can take the solids. Solids, aluminium, nickel, steel, iron, brass, glass. So everywhere you see that aluminium 6420 meter per second, nickel 646040, iron, steel, everything extremely high, very faster it is traveling. So compared to air, it is many times it is greater. Am I right, Ragan? You all understand?
Yes,
Everybody?
sir.
Yeah, if you take the liquids, water, seawater contains what? Seawater contains
Salt.
what?
Salt.
Impurities. You cannot say salt. Impurities. So which is density? Water of sea and water of distilled. Distilled water means pure, only water. So distilled. Which density is greater? Density of seawater. Density of seawater is greater than density of distilled water. Do you all clear, guys? Do you all understand?
Yes, sir.
Yes, that is
Yes.
so. Then
Yes, sir.
ethanol, methanol. Clear? Ethanol, methanol. So ethanol and methanol. Methanol actually ethanol after will come. Methanol after ethanol will come. So speed is see that it is varying. Now I told you now we have studied in physics. Yeah, physical properties, gradation in physical properties. Methanol to ethanol, understanding, increasing mass, atomic mass is increases. Chemistry we studied. Do you all
Yes,
understand,
sir.
guys? Please respond. So now in which one it is, in which one, am I audible, everybody? In which one it
Yes,
is
sir.
greater speed? You can see that, ethanol or methanol? In which one it is higher speed? Yes,
Ethanol.
methanol. Methanol, ethanol, ethanol. Clear?
Ethanol.
Yeah, ethanol also we can call it as ethyl alcohol. What is to call? Ethyl alcohol. Okay, so please write C2H5OH, ethyl alcohol. Puri mama.
Yes, sir.
So methanol, if you have been taken, CH3OH. So now which is atomic mass, molecular mass, which for which one greater? Ethanol or methanol?
Ethanol.
With
Ethanol.
ethanol molecular mass is greater. That's why speed of ethanol is greater than methanol. Have you checked it, everybody? Clear? I want response from people.
Yes, sir.
And that is
Yes,
what.
sir.
Next. But have you checked it? Gases, it is not little bit different. Hydrogen even faster than ethanol. That's what I says. But that's why I says generally gases least speed. But some gases it may be higher. Next, helium, air, oxygen, sulfur dioxide. So this is what is the thing you have to remember. Speed of sound in different media. So in which speed of sound is a rate of transfer of disturbance from one point to another point. That is what we used to say is the speed of sound. Please write it. Very, very important statement. What is the statement you have to remember here? Speed of sound is the rate of transfer of disturbance disturbances from one point to another. From one point to another. Clear, everybody? Yes, please.
Sir.
Yeah. So that's what we used to say. So rate of transfer of disturbance. Disturbance means what? Rate of transfer of anybody. Rate of transfer of energy. Rate of transfer of energy. Clear? Agalya? Sangamitrai?
Yes, sir.
Yes. Please make it. Mukesh, clear, Mukesh? Pranav?
Yes, sir.
Do it fast. Completed? So this is what it about it. So any doubt you can ask me. So now before going to the next word, that is what reflection of sound. So I want to teach you one more thing, which is very important for you. So now 3 points you have to remember. Speed of sound in air. 3 different temperatures they have given. At 0 degrees Celsius, 344. So 331. At 22 degrees Celsius, 344. At 25 degrees Celsius, how much it is? 346. So exactly you all need to remember. But what about the speed of light in air? Speed of light in air. Anybody? Speed of light in air. I have taught you. Light will travel faster in gases. So what is the speed of light in air? Nobody? 3 into 10 power 8 meter per second. Do you all remember? Yes, please.
Yes, sir.
Represented with the C. So please write it. So this is what we used to call it as speed of sound in different mediums. Now, the most important thing I'm going to say, so which you'll never see in our NCERT, so but you have to. So how many of you know fighter planes, fighter jets? Nowadays, our Indian government, also our Indian DRDO, armies, all are nowadays frequently you can hear about this one. We purchased also many things, fighter planes, supersonic fighter jets. Am I right? Have you heard it? Supersonic or normally jet planes you might be, fighter planes, fighter jet you might be heard it. Is it right, guys? Nobody.
Yes,
That
sir.
is what. All are busy with the serials, movies and all. No, no general knowledge. Huh? Even we purchase, our Indian government purchase from France and all nowadays many fighter jets. And even recently our Indian local made. That's what our make in China, make in India movement. We have designed one fighter jet of our own. So there are many things we are doing it. So that is what I am talking about now. Sonic boom. So this is one of the most important one. So what does it mean? Sonic boom means, remember, when a body, any kind of body, so why they are called it as a supersonic fighter planes? Reason behind is, so what is the at 25 degrees Celsius, what is the speed of sound in air? Everybody? Speed of sound in air.
46.
Yeah.
346 meters.
Yes, yes. Speed of sound in air is 346 meter per second. Now, if anybody moves with a speed greater than the speed of sound, then the speed of sound is called it as supersonic speed. What is to call? Everybody?
Supersonic.
Supersonic speed. For example, you are running more than 346 meter per second in air, then you are actually a supersonic speed. So that's why jet aeroplanes, rockets, fired bullet, etc. This all with what speed they will go? Supersonic speed. Do you all clear, Amma? So
Yes, sir.
that's why, sir, what is this? When a body says, like for example, a bullet moves with a supersonic speed, a shock waves are produced in air. That shock waves carry extremely large amount of energy. Understand? And they will produce a very sharp and loud sound. That sound is only called it as, you might be understand. What is the name of the sound? Everybody. What is the name of the sound?
Sonic boom.
Sonic boom. Sonic boom. Okay. So I will show you. sonic boom. So one of the most important, if you go future, anybody like research anything, you can even you can like any DRDO and all, if you join it, you can all go through this one. So basically jet planes and all it will be creating. So very sharp sound it will be producing, very extremely transfer of high energy it will be. So this is what fighter jets we are having. You might be noticed it recently, we are all making it. So have you noticed that there is a large and sharp disturbance in this? This is what we used to call it as sonic boom. You can notice it. When the jet planes are traveling more faster than the speed of sound in air, it will produce a very sharp and loud sound. That sound is only we used to call it as, what is the sound we used to call? Sonic boom. So this sonic boom produced by aircraft, basically our aircraft also will be like this. So at low altitudes, if it is traveling with a low altitude, it can shatter the glasses. Have you noticed that movies and all, some movies we can notice it. When the planes are moving any near to the glass, like buildings where it is a glass doors and all the doors will break. Am I right? Window panes. Am I right or wrong? Please respond. What is the reason? And also, have you remember when the aeroplane is passing near to that, or helicopter is passing near to that, very